All right, so once again, our objective for today, we're showing on I can factor quadratic trinomials with leading coefficients greater than 1. However, today's lesson is going to focus on special products. That's why the title of the lesson is Factoring Special Products. We already know what quadratic trinomials are. That's why we're not going to use the Freire model. We know what they are. We don't need the steps because we already know the steps, right? It's 6 easy steps. We factor out the greatest common factor, open two parentheses, factor the rest of the terms, draw a diamond and factor the last two terms, write your factors and check. We already have those steps, right? All right, so we end up here on the Q side. Everybody with me? On the Q side of your notes, I want you to write the first term. The first term, I'm going to call it the perfect square trinomial. Trinomial. On the Q side of your Cornell notes, write this down. Skip about 1, 2, 3, 4 lines, and then I want you to write the other type of special product that I'm going to show you today called difference of squares. Now, it's fairly simple, but it's so simple that some of you are going to miss it the first time. So I need you really focused on this, okay? And it's going to go pretty fast. Here we go. Pens down, eyes up here. First of all, let me clarify what perfect square trinomials are. Before I do that, though, I'm going to explain what a perfect square is. We covered this at the beginning of the year. Remember when we got into square roots at the beginning of the year? Yes? That we did the factor trees and all that? So a perfect square number would be this one, 12. Why is it my bad, it's not 12. 144. There it is. This is a perfect square. Why? Because this one comes from two numbers that are the same and it's their product. Are we there so far? 104 is a perfect square. Now, so that you can visualize it, here it goes. Here's a square. 144 is the area, so what would be the dimensions of the square? 12 times 12. That's why this number is a perfect square. Another way of writing this would be like this. 10 plus 2, isn't 10 plus 2 the same as 12? So therefore, if I'm using the area model, what would be this dimension? 10 plus 2. So check this out. 10 times 10 is 100. 10 times 2, that's 20. 2 times 10, that's 20. And what is 2 times 2? 4. Now check this out. Let me show you what a perfect square trinomial is. 100 plus 20 plus 20, that's 40 plus 4. Now, here I'm using numbers. Aren't all these coming from here? And what was this original number? 144, right? And what did we say? That 144 was a perfect square, wasn't it? But isn't this a trinomial? 1, 2, 3. So therefore, this is a what? Perfect square trinomial. Today I'm going to show you a pattern as to how to simplify perfect square trinomials without having to do the whole parentheses thing and the diamond and all that. Just by looking at a pattern. Check this out. And this is a pattern. If I was to give you, watch, if I was to cover this, and I was to give you this and I would ask you, check and see if this is a perfect square trinomial. This is how you would check it. Watch. Square root of the first term is 10. Square root of the second term is 2. If I multiply those, whatever that is, times 2, that should give me the middle term. Let's see. What is 2 times 10? 20. What is 20 times 2? If it does give me the middle term, then this is a perfect square trinomial. And if it is, then you already know the dimensions. Check this out. My factors will be 10, and instead of this, we use the middle term, which is plus 2 squared. And those are the dimensions of the square, yes. What's that? That's cool, right? And I'll show you how it works right now with the actual polynomial. So copy that, so like that, at least you have that as a reference. And you remember that this is just with numbers. I'm going to show you now with variables once we get there. Go. Copy that, please. Okay, now the second term, guys, so now I kind of explain what a perfect square number or a perfect square trinomial looks like with numbers. Now let me explain what difference of squares means. Pens down, eyes up here. The word difference, it implies an operation. What operation is that? Subtraction. And if it says difference of squares, what does that mean? That we're going to subtract one square from another square. Everybody with me? So what if this one was 144 and this one was 9? That's what difference of squares means. Okay? Now let me show you in terms of this. This would be 10 plus 2, 10 plus 2. So that's 120, 24. And this one is just, let's see, what is it? 3 times 3. But it's what operation in between? Subtraction. Are we there so far? Okay. So that's pretty much what we're going to see in regards to difference of squares, but with polynomials, of course. Right? You're saying, okay, Mr. Hugh, let's get to it. All right, here we go. Copy this down. Example 1A. Write the instructions, please. It says, determine whether each trinomial is a perfect square. If so, factor. If not, explain. It says, determine whether each trinomial is a perfect square. If so, factor. If not, explain. Here it goes. So this is how we check. This is how we check to see if this is a perfect square trinomial. Here it goes. First things first, you need to find the square roots of the first and the last term. Pay attention first, don't copy anything yet. Square root of 81x squared, that's 9x. Square root of the last term is 5. If their product times 2 gives me the middle term, then this is a perfect square trinomial. Let's see. What is 9x times 5? 45x. 45x times 2, that. Then this is a perfect square trinomial. So it says, if so, factor. So check this out. This is how easy this is. My first term is 9x. My last term is 5. I use the sign of the middle term of the trinomial, and I write it squared. Why squared? Because it's a perfect square. And I'm done. Copy that, please. Write this down. If you want to write it right next to it, it's still part of example 1A, but I'm just going to call this one example Q. And write this down. I'm going to do 49x squared plus, give me a second. All right, check this out. Let's do, let's see, 42x plus 9. Let's see. Let's do that one together. Let's check to see if this is a perfect square trinomial. Here we go. First, we need to find the square root of the first term. That's 7x. Find the square root of the last term. That is 3. From there, we multiply those two, and then at the end we double it. Let's see. What is 7x times 3? 21x. If we double that, does that give us 42x? So this is a perfect square trinomial. So therefore, what are my dimensions? 7x plus 3 squared. And we're done. You see how that worked?
Yeah.
Okay, let's do another one. Let's go to that one. Here we go. Copy this one down. Example 1B. You don't have to copy the instructions anymore. You already have them. Just copy example 1B and copy the trinomial. 9x squared minus 15x plus 64. Let's do this one together. So let's see, how can we check to see if this is a perfect square trinomial? To see, we start with the square root of the first, right? What is that? 3x. Square root of the last? 8. So then we multiply, and whatever we get, we double it, and that should give us the middle term. So let's see. What is 3x times 8? 24x. What is 24x times 2? Is that this? No. So this is not a perfect square trinomial, comma, because, why not? Maddie? Because 24x times 2 does not equal the middle term, right? And let me show you why this we need to multiply times 2. Everybody look up. Watch. Look at this one. If I was to check this, pens down, please. I write 9x plus 5 times 9x plus 5. Are we there so far? Do you agree with what I've been doing so far? Yes, because it's a perfect square. So 9x times 9x, that's 81x squared. 9x times 5, that's 45x. 9x times 5, that's 45x. 5 times 5, that's 25. So let me ask you this. This is 45 times 2. How many times do you see 45 in this area? Twice. That's why it's 45 times 2. Everybody with me? So therefore, everybody look up. So what did this middle term need to be in order for this to be a perfect square? 48 what? 48x. This needed to be 48x, either negative or positive, in order for it to be. But since it's not, you'll just write because 24x times 2 is not equal to the middle term. Are we there? Okay, copy this next one, please. Example 1C. 1C. I just want to see if you see what I see. Example 1C. 36x squared minus 10x plus 14. Do that one by yourself. Go. That is correct. So this one is not a perfect square trinomial. Check this out. This one is 6x. This one, can we find a perfect square from that one? No. That's why that's not a perfect square trinomial. Do another one. Example 1B. 1B. Copy that one, please. Except, I'm sorry, this is example 2A. 2A. X squared plus 4x plus 4. Copy that? Okay, everybody done? Is this a perfect square trinomial? What are the dimensions? X plus 2 squared. Hands if you got that. That is correct, because check this out. This is square root of x squared is x. Square root of 4 is 2. 2 times x, that's 2x. If we double that, does that give us the middle term? Yes. Okay, let's do another one. Example 2b. Copy this one. Example 2b. X squared minus 14x plus 49. Copy that. Is this a perfect square trinomial? Give me a second. It is a perfect square trinomial. Okay, let's see. Let's double check. What is that? What is this? And that is 7x. If we double that, does that give us this? Yes. I know. Okay, guys. Here we go. Be nice. Here we go. What is the one thing that I said? As long as it equals to this, our factors are just going to use the sign of the middle term. So therefore, x, what? Minus 7 squared. Yeah, so check this out. So look at the previous one. This one was a positive. That's where we wrote plus 2. But this one has a negative. That's where you write x minus 4 squared. Everybody got it?
Yeah.
Okay. I mean, not minus 7 squared. Okay, copy this next one. Example 2C. Go. 9x squared minus 6x plus 2. I mean plus 4. I was just testing, guys. Example 2C. 9x squared minus 6x plus 4. This one is not a perfect square. Let's see. 3x. 2 times 3, that's 6x. Double that. Does that give us this? No. Not a perfect square. Square. Okay. So now, we're done with perfect square trinomials. Now let me show you difference of squares. Here we go. Copy this one down, please. Okay, pay attention to this one. Everybody look up. This one, it says, a rectangular piece of cloth must be cut to make a tablecloth. The area needed is 16x squared minus 24x plus 9. Let's check and see if this is a perfect square. Square root of 16x squared is what? 4x. Square root of 9 is 3. 4 times 3, that's 12x. If we double that, does that give us a middle term? So my dimensions are 4x minus 3 times 4x minus 3. Or are they talking about the area? What are they talking about? So it's 4x minus 3, 4x minus 3, and we add, right? Plus 4x minus 3 plus 4x minus 3. Why 4? How many sides does it have? 4, and it's the perimeter, right? So now, instead of x, what do we substitute? 11, and then we add all sides. Okay? So that's that one. But let me get to difference of squares. Copy this one down, please. Example 4a. Determine whether each binomial is a difference of 2 squares. If so, factor. If not, explain. Copy that. Okay, pens down, please. Eyes up here. First of all, who notices that it's no longer a trinomial? Okay, so right away, one thing that's going to distinguish difference of squares to perfect square trinomials is that it's not a trinomial. The second thing, the word difference means subtract. Does it have a subtraction sign? Yes. So those are two things so far that it could be a difference of squares. The third thing, we need to be able to find the square root of the first and the square root of the last. Pay attention, please. Square root of x squared, x. Square root of 4, 2. Is it a difference of squares? Yes, since we were able to find the square root. So check this out. These are my dimensions. One of them is a negative. The other one is a positive. And we're done. And you're saying, why that, Mr. Q? Let me show you why. Everybody look up. Hold on. Watch. If I was to rewrite this as a trinomial, x squared, what's missing in the middle term? An x, right? So I would write 0x. And what's my last term? Minus 4. So therefore, first term is x times x. Power Rangers. Okay, I'll stop. So, middle term goes here, 0. My product is negative 4. What factors of 4? Let's see, 1 times 4, 2 times 2. Add or subtract to give me 0. 2 and negative 2. 2 times negative 2 is negative 4. 2 minus 2, that's 0. X plus 2, x minus 2. That's why one of them has to be negative, the other one has to be positive, because there is no middle term. Check this out. If negative 4 was a positive, x squared plus 4, this will not be a difference of squares, because in order to be a difference, it has to be what? Subtraction. Yes, it has to be right away. So your homework for tonight, is found on page 518, 1 through 35. Odd. Enjoy your homework, guys. Tutoring today. Turn in your homework on your way out, including your signed progress. See you guys tomorrow.